All right, hey guys. I'm going to do a just a short video walkthrough of number 8 um, uh, from the study guide problems for Unit 6. Okay. Um, so, excuse me. All right. So we have the inner reaction of 15.3 grams of NaCl with 60.8 grams of PbNO32. How many grams of lead 2 chloride will be produced? What is the limiting reactant, and how much excess reactant is left after the completion of the reaction? So we've got two masses here. Both things are reactants. They're on the left side of the equation. They're asking for an amount of product, grams of excess reactant. So that means we are going to have to run a BCA chart. So I don't have to rewrite the equation. I'm just going to do that right under here. Okay. And first thing is we're going to convert grams into moles. Okay, so I'm going to do 15.3 grams of the NaCl. The grams for the NaCl is 58.5. For 1 mole. Right, and this comes out to be 0.262. We want to take this number to at least as many significant figures as we start with here, so we don't want to round it too early. Moles of NaCl. Okay, so remember, this was the grams we started with. That means this is the moles we start with because we just converted grams to moles. So this is the amount of moles that we start with. So that's going to go up here in the before row under the NaCl. So 0.262, right? And then I'm going to turn the 60.8 grams of the PbNO32 turn that into moles as well. So when you're doing the grams for the PbNO32, remember, any number outside of parentheses, like subscript like this, you multiply times any subscript that's inside. So it doesn't go to the PB because the PB is not in the parentheses, but so there's one of the PBs, there are 2 of the nitrogen, and there are 6 of the oxygen, and you multiply by the masses and add it all up, right? So that if you've done it correctly, that comes out to be 331.2 grams of the PbNO32, okay, for 1 mole. And this gives us 0.84 moles of PbNO32. Okay, oh, and so that's our moles for that one. So we're going to put 0.184 there. Okay, and for our product for the before row, remember there is no product before the reaction occurs, so those are zeros. Okay. All right, now to find the limiting reactant. To find the limiting reactant, we have to take our number of moles and divide by the coefficient. So in front of the NaCl, there's a 2. In front of the PbNO32, there's nothing, so it's just a 1. So we get, this is, let's see, 0.131. And this is going to be the same, 0.184. Now, after you divide it by the coefficient, you compare whatever the smallest one is, whether you have 2, 3, however many, the smallest one, that one is tells you what the limiting reactant is. So I'm going to put it up here. Our limiting reactant is this one, NaCl. All right. So we've done what is the limiting reactant part. Now to get the other ones, we've got to finish our BCA chart. So to get our change row, you take the smaller number, the one that gave you the limiting reactant, and you multiply it times the coefficient for each one. So 0.131 times 2 is going to give me 0.262 times 1 times 1 and times 2. That's our change row. Now, we're going to subtract, to get the after row, we are going to subtract reactants and add products. So that's a 0. This comes out to be 0.053. This is 0.131, 0.262. Okay. So now we have all this information. Remember, one of the most important things to remember about the BCA chart itself is that the entire thing is all in moles. Okay? Everything you put into the chart should be in moles. Everything you get out of the chart is in moles. So how many grams of lead 2 chloride will be produced? So lead 2 chloride is this one, lead and the chlorine. It's this. The stuff we have after the reaction is down here, 0.131. We want that in grams, so we're going to do 0.131 moles of the PbCl2. Make sure you're using the right substance. Okay, we're going to convert moles of PbCl2 into grams. So the mass of PbCl2 comes out to be 278. Okay, and this comes out to be, significant figure should be 3, so this comes out to be 36.4 grams of the lead 2 chloride. So that answers that part. Now, third part here, we've done the limiting reactant. How much excess reactant is left after the completion? So excess reactants, remember, are on the left side of the equation. So looking here, after the reaction is done, what has stuff left over on the left side? Well, it's the PbNO3 So we take that, and we are going to convert into grams, and that gram we've already figured out up here, right? So 331.2. Okay, we do the math here, and the answer is 17.6, or if you went by this for significant figures, it'd be 18, either way, grams of PbNO3. And that's it for number 8. Okay.